Hi everyone, in this video we will discuss the problem minimum element in a BST. So basically the problem says that we'll be given the root of a binary search tree and our task is to find the minimum value element in this particular BST. So let's take the first example. Suppose we have got the tree as 5, then for 5 the left child is 4 and the right child is what? The right child, let's say, is 6. Then for 6 the right child, let's say, is 7. Then we have got 4, and for 4 we have got the left child as 3, and for 3 we have got the left child as 1. Suppose this particular tree has been given to us. So what you will do here is, if you will observe, so what is the property of a binary search tree? The property of a BST is that whenever there is a particular node, so all the elements on the left of that node are lesser than that particular node, and all the elements that lie on the right of that node, on the right subtree of that node, they are having values greater. So one thing that you can observe from this particular given test case is that, suppose that if you currently start from 1, so you can currently start from the node, let's say 5, that is the root node. Now whenever you want to find the minimum value, so going to the right of a node will always increase the value. So in which direction you would like to go? Whenever there is a current node, so you will always like to go on the left, because the left will always be lesser than the current node. So currently we are at the node 5. Okay, since the left child exists, so we'll go to the left child. Now since 4 exists, so we have gone to 4. Now after that the current will become 4. Now for 4 also the left exists, so we'll go to 4. The reason why we are going 4 is simply because the left child will have the value lesser compared to the current guy. So now for 4 the left child was 3, so we have gone to 3. Now for the current node as 3, it has got a left child, so we'll go to that left, and currently we are at 1. Now when you are at 1, so again you will check, is there any left child? No. Since there is no left child for 1, then you will stop here, and this is the minimum node. So this is the minimum valued node. So you can see that current is at 1, and this is the minimum valued node of the BST. So you can see here, basically the scenario is that whenever you are at a particular current node, if you go on the right of that node, then the value is going to increase. If you go on the left, so the value is going to decrease. So ultimately the consideration here is that whenever we are at the current node, so you would like to go on the left, because if you go on the left you will get a lesser value, that is for sure, considering the definition of BST. So that is why whenever we are at a current node, if the left exists, go to the left, and we keep on repeating this process until the left does not exist. So whenever the currents left become null, then we have stopped the process. So for 1, its left was null, so we stopped the process, and current was standing here, so we return the current node's data. Let's try and see it for the second test case. Suppose we had 9 and then we had 10 on the right, and then we had 11 on the right. So when we had been given this particular example, so current will start from the root, so current will start from 9. Now when we are at 9, so on the left, for 9 we will check that is there any child on the left. No, there is no child on the left, so we have to stop this process here, because if you go on the right of this node, so always the values will be greater, and since there is no left child, so this means this is the minimum node, because for the current node as 9 there does not exist any left child. So that is why we'll stop there, because the current left is null, current is 9, its left is null, so we will return the current node's data only, that is 9, and it is the minimum value of the given BST. So I hope that you have understood this approach. If you will see the time complexity, so in the worst case what can happen is the tree can be skewed in one particular direction, either it can be towards the right side or it can be towards the left side. So in the worst case all the end nodes can be in one direction only, so that is why the time complexity taken in the worst case would be order of n. Space complexity would be order of 1, because I am not taking any extra space, neither recursion nor any extra data structure. Let's try and implement this to check if it can get accepted or not. So as I said, what we will do here is, first of all we'll declare a node star current is equal to the root. So we'll start from the root node, and then what we will do is we'll say that while the current node that we are at, its left is not equal to null, till that point of time we'll iterate. Okay, so we'll say that current is equal to current's left. So if the left child is not null, we'll move on to the left child. Okay, then once this is done, then after this we will simply return the current's data, because whatever current we are standing at the last, its left would be null, so it will be the smallest valued node, so we'll return its data. Okay, let us now try to compile this to check if it can get accepted. So it is working fine on the sample test case. Let's try and submit this code. So you can see that my code was able to pass for all the 1115 test cases. Previously this problem has been asked in Microsoft. So I hope that you are clear with the complete intuition of this problem. If you have understood this problem, please make sure to comment down understood or +1. Thank you for watching this video and keep coding, guys.